So let us start our class, Thermodynamics. When we come to thermodynamics, we have a definition for thermodynamics and then what it deals in thermodynamics we discuss here, and then system and its surroundings. The points here we have microscopic and macroscopic parameters of the system. Third one. Fourth one is thermodynamic equilibrium. Fifth one is equation of a state, concept of temperature and heat and work. All these things here we discuss. The main points in this class we discuss are thermodynamics. What is thermodynamics? What it deals, system and its surroundings, macroscopic and microscopic properties of a system, thermodynamic equilibrium, equation of state, concept of temperature, heat and work. So when we come to thermodynamics, in that name, thermo means heat, related to heat. Dynamics, that means uh, conversion of heat into useful work. Dynamics means how we convert, how we use heat into work. All these things here we discuss. So thermodynamics it sounds the heat concept, thermal or heat. So what is thermodynamics? How we can say this? Thermodynamics is a branch of physics which deals with the heat or heat energy. How we convert heat energy into work or vice versa. How we convert mechanical energy into heat or some other energy into heat. So all these things are discussed in thermodynamics. Heat, how heat is converted into work, and how the work or some other energies into heat. The things here we discuss in thermodynamics. So in this process or in this point, mainly concentrated about heat. In next topics, we discuss about heat and work. Before going to discuss about heat, what is heat? Here, as per our preparation slides, we follow the order. Okay, so now thermodynamics divided into two parts. One part deals with the heat. First part deals with the relationship between different types of energy based on first law of thermodynamics. That means energy, how the energy is, heat energy is conserved, how we can convert into useful work. The second part is the direction the heat goes. That is based on the second law of thermodynamics. So After these discussions, definition of thermodynamics and the division, we have a points. What is heat? We have a question. What is heat? And then, what is first law of thermodynamics? What is second law of thermodynamics? The first law, second laws of thermodynamics are discussed in some other day, but it relates with energy. We know here uh, when we say thermodynamics is divided into two parts. One is deals with the heat energy, the conversion of heat energy, a relationship of heat energy based on the first law of thermodynamics. That means the first law of thermodynamics deals with conservation of energy. That thing we can discuss in future classes or coming classes. In coming to second part, it deals with the direction of heat flow. Uh, from which side to which side the heat can flows. From where to where heat flows. That things are discussed in second part. That is based on second law of thermodynamics. So the second law of thermodynamics maybe deals with the direction of heat flow. In which direction the heat flow takes place. So from these points we have these things based on the definition of thermodynamics. We observe 3 points very important. The thermodynamics based on the heat. So what is heat? We know generally what is heat. And in this thermodynamics we have laws. Here we observed the terms first law of thermodynamics, second law of thermodynamics. First law of thermodynamics relates to conservation of energy. Second law of thermodynamics relates to flow of heat energy. So these things are clearly uh, understand in few classes or in coming classes. So that is about thermodynamics. Okay, one point here. Next one is system and its surroundings. Where we observe the system and its surroundings. Why it is system? That means here in the thermodynamics definition, heat energy is converted into work. So where heat energy is observed means a thermodynamical system. A system which absorbs heat or emit heat is treated as a system or a body. Every body may be treated as thermodynamical system which absorbs heat and energy. That is the thing. So system means a body or an object which may absorb or emit heat. When we consider an example, a gas contained in a cylinder may be treated as a system. A gas contained in a cylinder with a movable piston constitutes the system. Here also we have a definition about system. A definite quantity of the matter bounded by some closed surface is known as a system. A definite quantity of matter bounded by some closed surface is known as a system. Means a matter or a body which responds to heat, which is acts on a heat, is treated as a system. So the system consisting from this sentence, it sounds system consisting matter and a bounded surface or a closed surface. Okay. Now you can uh, observe these things very interestingly. System consists a matter and a surface. In future topics that may be Carnot's engine. There we observe these two terms, matter and surface, consists or constitutes a system. Here, in example, we say that a gas contained in a cylinder with a movable piston. Gas is a matter. Cylinder with movable piston is a closed surface. Here we can observe these things. We can understand those things. Okay. In this topic, we have system and its surroundings. The surroundings which influence the system is called things which influence the system are called as surroundings, whatever it may be. For example, in case of gas contained in a cylinder, the atmosphere may be treated as a surroundings, or a room where the cylinder is placed is considered as a surroundings. After the system, the things which are near the system is called as surroundings. For example, when we cook the rice, the bowl and rice with water is treated as a system. The surroundings surroundings near the bowl, which affects the system, is called a bowl is called surroundings. For example, in this case, we clearly observe in summer. In summer, the food may be prepared easily within 20 or 25 minutes because in surroundings we have a high temperature. Whereas in winter, it may take 25 minutes to cook a rice, to prepare a food. That is the atmosphere situations is treated as surroundings. In order to clear the sense, we discuss more. So that may be no problem. Okay. So the choice of the system, maybe it is quite arbitrary as per our interest may consider uh, one part may be a system or one part may be surroundings. That is our uh, limitations. As per our requirement, we divide the system and surroundings. That is no problem. So, and coming to systems, we have three types here: open system, closed system, isolated system. Open system, closed system, isolated system. In case of gas contained in a cylinder with movable piston, the gas may exchange energy or itself. It may be exchange energy or itself come to surroundings and enter into the cylinder. Maybe two cases are possible. That means if the system exchange both energy and matter, that means gas, in the case of the gas contained in a cylinder with movable piston. If both are exchangeable, then the system is called as open system. That means when we boil the water vapor may enter into the surroundings. Similarly, the heat may enter into the surroundings. That type of system is called open system. If the system exchange only energy, not a matter, then those are called as closed systems. Only energy. They cannot exchange matter. Those are called as closed systems. For example, pressure cooker. it can exchange energy to the surroundings, but it cannot exchange matter. So the types of systems are called as closed systems. Isolated system, they neither can exchange heat nor exchange matter. Those are called isolated system. So the classification of systems comes due to the exchange of matter and energy. Matter and energy. This is the about system and surroundings. System means a definite quantity of the matter bounded by the some closed surface is known as a system. Surroundings means all those things which are considerable or which are outside the system and influence its behavior are known as surroundings of the system. Systems are classified into three types based on the exchange of energy and matter. If both are exchangeable, then those are open. If energy is exchangeable, those are closed. If neither can be exchangeable, that is isolated system. So in this uh, today's class, we complete two topics: thermodynamics, system and surroundings. And next important one is macroscopic and microscopic properties of the system. Which properties which, uh, comes into observation for a system. So those properties are divided into macroscopic and microscopic properties. What it deals, the macroscopic properties are what tells. Similarly, microscopic properties are what tells about the system. So when we come to the macroscopic properties, they describe the gross characteristics of the system. They can be measured directly in laboratory. They can be experienced directly by our sense of perception. So macroscopic, macro means we can observe directly by our sense and can measured, can be experienced, can be tells about the gross characteristics. Those means macro. Macro means overall properties. So it is concerned with the, it cannot concerned with the structure of the system. It deals with the general properties. General properties are not concerned with the structure of the system. Those are very important in this: pressure, volume, temperature, internal energy, and entropy. Pressure, very important. Macroscopic properties are important physical parameters in this thermodynamics are pressure, volume, temperature, entropy. Internal energy may come sometimes, but frequently we observe the PVTS, pressure. P means pressure, uh, T means temperature, V means volume, entropy, S means entropy. These are the important macroscopic properties of a system. Microscopic, coming to the microscopic properties, those describe the internal structure of a system. For example, in case of gas, the gas consisting some atoms or molecules. For example, carbon dioxide gas, in which there is CO2 molecules. In case of water vapor, there is H2O molecules. In case of helium gas, there is helium atoms. Like that, we have, in order to describe the internal structure, we deals with the microscopic properties. Those microscopic properties are mass, velocities, energies, momenta. So these are in our syllabus. These are very rarely we observed in our thermodynamics. So most of the our syllabus consisting PVTS parameters. Okay. So when coming to the microscopic properties, those describe the internal structure of a system, cannot be measured directly in laboratory, cannot be experienced or sense of perception. Is similar to the macroscopic, there is here opposite sense is there. Macroscopic properties describe the gross characteristics, whereas microscopic properties describe the internal structure. Macroscopic properties measure directly in laboratory, whereas the microscopic properties cannot measure directly in laboratory. Uh, the macroscopic properties can visualize as per our sense of as per our sense. Not visualize, we can experience the sense of by our sense of perception. But in case of microscopic properties, we cannot experience by our sense of perception. So these things comes under macroscopic and microscopic properties. The parameters which we mention regarding microscopic properties, those are masses, velocities, energies, and momentums of individual molecules or individual atoms. That is about microscopic and microscopic properties of a system. For example, when we relate the both uh, macroscopic and microscopic properties, the macroscopic property comes by the microscopic property. When we say the temperature is a macroscopic property that may be observed from the kinetic energy of gas molecules or kinetic energy of a molecules of the system. The kinetic energy of the molecules of a system is a microscopic property, whereas the temperature of a system is macroscopic property. That is the relation between microscopic and macroscopic properties. So up to this, we have discussed about thermodynamics and then system and surroundings, macroscopic and microscopic properties. Now we come to thermodynamic equilibrium. Thermodynamic equilibrium. If a thermodynamic system, is said to be in thermodynamic equilibrium, it follows three equilibriums, that is mechanical equilibrium, thermal equilibrium, chemical equilibrium. Then we say that the system is said to be in thermodynamic equilibrium. So all these three equilibriums is satisfied, then we say that a system is in thermodynamic equilibrium. So here, what is mechanical equilibrium? What is thermal equilibrium? Chemical equilibrium? Mechanical equilibrium of a system means the mechanical energy of a system remains constant. The mechanical energy of a system remains constant. That means you cannot uh, give the more energy to the surroundings, or it cannot absorb the more energy from the surroundings. So it balance the mechanical energy of a system is balanced with its surroundings. Then the system is said to be in mechanical equilibrium. In case of mechanical equilibrium, we have here pressure, volume, temperature remains constant when the system is in mechanical equilibrium. Next, thermal equilibrium. The temperature, thermal means here, thermo, in the thermodynamics, I say that thermo related to heat. Here, thermal means it belongs to single quantity, thermal temperature. When you say thermodynamics, it is a large concept. It constitutes pressure, volume, temperature, entropy, and internal energy, all these macroscopic parameters. When we consider thermal equilibrium or thermal, here we say that temperature, it is mainly depending upon the temperature. Thermal equilibrium means the temperature of a system is constant with the surroundings and its remaining parts of a system. Then we say that the system is in thermal equilibrium. Third one is chemical equilibrium. Means chemical composition of a system is constant throughout the system. Chemical equilibrium means chemical composition of a system is not varied from one place to another place of a system. Throughout uh, in an example of gas cylinder, gas consisting in a cylinder with movable piston, the gas molecules are same in everywhere of the uh, cylinder. Those molecules may not differ from one place to another place. That means the system is said to be in chemical equilibrium. So all these three equilibriums are satisfied, then the thermodynamic system is said to be in thermal equilibrium. So up to this, we discuss about thermodynamics, system and surroundings, macroscopic and microscopic parameters, and thermodynamic equilibrium. In thermodynamics, we observe in the sub topic of thermodynamics, we observe three quantities: heat, and first law of thermodynamics and second law of thermodynamics. Those are very important one. In system and surroundings, we observe the different types of systems, and macroscopic and microscopic parameters. We note the macroscopic parameters: pressure, volume, temperature, entropy, internal energy. And in thermal equilibrium, thermodynamic equilibrium, we have three types of equilibrium. All these things are discussed. Now, coming to fifth one, equation of a state. Equation of a state. That means the state means how the system behaves at certain point of time. That is the state. For example, in daytime we are moving or we are doing something. In night time we are kept quiet and go to sleep. That means that is our state, general thing. In similar sense, a thermodynamic system, in every time there may be a state, there may be a certain condition. How we represent the condition of a thermodynamic system comes under this equation of state. So every state, every condition of a system is described by using an equation is called equation of a system. Here in general parameters used to describe the state of a system are pressure, volume, and temperature. Certain times entropy may be included. Entropy may be included. This is the equation f of pvt equal to 0. So a state of a thermodynamic system is described by using three variables: pressure, volume, temperature is called a state of system. In these three variables, two are independent variable, one is dependent variable. Two are independent. Those are independently changing based on the third dependent variable. So when we know two parameters, we can measure the state of a system. In intermediate classes, we observe the Boyle's law. Boyle's law. Based on that Boyle's law, and temperature of a system is constant, pressure of a system is inversely proportional to its volume. P is proportional to 1 by V, or P is inversely proportional to V. Both are same. P is proportional to 1 by V. That means PV is equals to constant. Very famous equation based on the uh, thermodynamical parameters, pressure, volume, and temperature. So that Boyle's law states an equation for a system and temperature is constant. Their temperature is dependent variable. P and V are independent variable. P is inversely proportional to volume. So here also we have another relations. PV is equals to RT. PV is equals to RT. This is ideal gas equation. So we have 40 minutes. Here is a warning. After 5 minutes, the class will be closed. Remaining points may be discussed in next class. If any doubts, please raise your queries. Okay. So from ideal gas equation, we have PV is equals to RT. Pressure, volume, temperature. This is an equation represents the ideal gas at any state. Similarly, for van der Waals gas or laboratory system, we have P plus A by V square into V minus B is equals to RT. Here, the additional term in pressure A plus V by square is treated as internal pressure of a system. Similarly, in volume term, P is relates to the volume parameter or volume constant. It is differ with the different molecules. So that is comes into place. Actual gas or laboratory gas or van der Waals gas. This is the not an ideal gas. This is real gas or actual gas or actual laboratory work gas. So the ideal gas, the van der Waals gas or real gas satisfy the equation P plus A by V square into V minus B is equals to RT. Okay, so uh, any doubts you have, please raise your queries or questions regarding thermodynamics, system and surroundings, macroscopic and microscopic properties, thermodynamic equilibrium, and similarly the equation of a state. So in this class, we discuss about uh, what is thermodynamics. There we observe some important words: heat, laws of thermodynamics, system and surroundings. There we have three types of systems, and then macroscopic and microscopic parameters. There we have uh, important parameters used in thermodynamics: pressure, volume, temperature, and entropy. Fourth one is thermodynamic equilibrium. Why we deal with thermodynamic equilibrium? Now I have a question. Why we deal thermodynamic equilibrium? Some other cases there may be thermal equilibrium. Some other cases there may be chemical equilibrium. In some other there may be mechanical equilibrium. When we consider vaporization or liquefaction, there may be thermal equilibrium is observed. That means temperature remains constant when water changes from water to water changes to ice at 100 degrees temperature. Their temperature is a constant parameter. That is, those things you can observe. Hence, we deals with the thermodynamical equilibrium. In earlier classes or in intermediate classes, we observe the boiling of a water, boiling point, measuring the boiling point of a water, measure the uh, liquefaction of water. That is, when ice changes into water. Those things are discussed in intermediate classes. So,